Hey everyone, and welcome to a new video on this channel. And we continue the series we started on Dapr. And today we'll look at doing PubSub with Dapr. In the previous video, we looked at state management, things like, for example, remote service invocation. And we did this on the local machine, so during development, and we also did this on Kubernetes. So this time we'll look at PubSub, and we'll also deploy it directly to Kubernetes to see how this works. Now, just like with the other examples or the other features provided by Dapr, our code or containers that run our code will use a Dapr sidecar container within the pod that they are deployed to do their actual work. So it's the same thing here with PubSub. I have a publisher that wants to publish messages to a PubSub system, and that's of course the system underneath is abstracted away by Dapr. So the publisher just posts messages to a endpoint on localhost, so provided by the Dapr sidecar, and then Dapr does its magic by posting to the underlying system. So if the underlying system is Redis Streams or Azure Service Bus or something else, I don't have to know about this. Dapr will take care of that. Now, a publisher is a fairly simple thing. It just has to post a message, a JSON message, for instance, to the Dapr sidecar. The subscriber is a little bit more complicated, not very complicated, but the subscriber has to provide an endpoint because the subscriber has to indicate to Dapr, first of all, the topics it is interested in. And then it also has to provide an endpoint where Dapr can post the messages to. So it's not your subscriber code that has to connect somewhere to retrieve messages. No, you will get the messages delivered to you by the Dapr sidecar. And Dapr is responsible of connecting to the underlying PubSub system in the proper way, using the proper message handling for each kind of underlying system. And it will then post the messages that you're interested in. Take into account that, for example, here I can easily scale up my subscribers and use multiple replicas. And Dapr will take into account that I have multiple replicas and make sure that he doesn't deliver duplicates of all these messages to all the subscribers that are listening. These are all things that I don't have to take care of myself. That's something that Dapr provides. Good enough theory. Let's look at how this works in code. And remember, again, this is not really about the code. This is about how Dapr works and how it provides this functionality. The code is kept intentionally simple, and typically I'm using the sample code that Microsoft has provided as let's say, a starting point. In this case, this is the publisher. So as I said, the publisher just needs to send its messages to a local endpoint. So the endpoint is, of course, on localhost on Dapr port 3500. And as you know, the containers within a pod, they share localhost. So if there's one container running on one port, say Dapr port 3500, my own container can just connect to localhost on that port to connect to that sidecar container within the pod. So it's connecting to Dapr on localhost at the Dapr port of 3500, which is the default one. And then to publish a message, it just has to do a call to v1.0/publish and then the topic name. The topic name in this case is just a variable. I can set the topic name using an environment variable here, or if that one is not set, and in this case it is not set, we'll just use the topic called sample topic. The code that sends the actual topic is just HTTP code, so we post our message to this publish URL here. We do this with Axios post to the publish URL. This is the message we are posting, which is a simple JSON structure with an increasing counter, nothing special. And then we log when there's a successful post, and we also log when there's an error. And we repeat the message sending. Every 5 seconds, we send a message. So the publisher is, of course, very simple, and that's what you see here. The publisher is just posting messages to a local endpoint, but it's provided by the Dapr sidecar, right? Let's look at the subscriber. Subscriber is also simple, but it's a little bit more complicated. Why? Because we have to, of course, provide some information to Dapr and say what kind of topics we are interested in, right? So this application, so this subscriber, although it's just subscribing, it needs to provide an endpoint that Dapr can connect to. So Express is used to provide these HTTP endpoints. Express is listening on port 3000. And then to indicate what topics we are interested in, you have to provide an endpoint that Dapr can connect to. And Dapr will do this for every container, for every system that is told to connect. You'll see later how that is done by doing a get to Dapr subscribe. And you just return an array of topics and routes. In this case, the array contains only one topic. I'm interested in the sample topic. And when a message is in the sample topic and needs to be delivered to my subscriber, then Dapr should post to the sampler route. That of course means we have to implement the sampler route, which is implemented here. We just log the message, which is inside the body of the post request. And then, and that's of course quite important, we have to indicate if the message was successfully received. If, for example, something goes wrong and you have to send something else, then OK 200, right? And then, of course, Dapr will do certain things. For example, do retries and so on. And maybe if it has retried too many times, put the message into a dead letter queue and so on. These kind of things. So depending on the system that's being used in the backend, Dapr will do the appropriate thing when errors start to occur. So in this case, we only indicate successful receipt. We could have modified this a bit to once in a while not have a successful receipt and then see what happens. But maybe some other time we'll do that. Yeah, this is our subscriber. Now, of course, both our publisher and subscriber, they have a Dockerfile. I already created the Dockerfile, the container images. I pushed them already to our repository, so that's all fine. We have them. That's quite basic Docker stuff. Let's now deploy to Kubernetes. Of course, to deploy to Kubernetes, Dapr is already installed on Kubernetes, by the way. On my cluster, I installed Dapr using the Helm chart. Look at the Dapr docs to see how that works. To tell Dapr the kind of PubSub system we're going to use for our application containers, we have to create a component of type PubSub. So in this case, we indicate here, start with PubSub, the type name, it's a PubSub component, and this component is using Azure Services, or is defining let's say a PubSub system, which is Azure Service Bus. The only thing that we need to provide as a mandatory parameter is the connection string here, right? Now, maybe before I delve into how the connection string is retrieved, because we're using a secret for this, notice that the name is actually not used in the application code. If you look at the application code, we don't really refer to the name of the PubSub component. The reason is actually quite simple. There can be only one PubSub component at this point in time for a given Dapr instance. So Dapr is installed on our cluster. That's one Dapr instance. Well, that one can use one PubSub component. So I just need to define a PubSub component. I can call it whatever I want. When my applications want to do PubSub, they will use this defined system, right? Now, as you can see, the connection string here actually has a reference to a secret key, or has a secret key ref here, which properly recognizes is referring to a Kubernetes secret. So we actually tell the system, look, the connection string, you need to find the Kubernetes secret on the system. That Kubernetes secret should have a key called service bus. I can of course call this whatever I want. And I tell Dapr here that, yeah, indeed, we're using as a secret store, we're using Kubernetes. Dapr can use other secret stores, like Key Vault, for instance, or something like Vault from HashiCorp. These things are supported, but in this case, I kept it simple and we just use the Kubernetes-based secret. So I have to have a secret that contains the connection string. Now, in my case, I use an in-between component because I have that installed on my cluster. My cluster has some software installed that can take a look at Key Vault and convert Key Vault secrets to Kubernetes secrets. You can look at it up. You can look it up here if you search for spv.no or Azure Key Vault secret. You'll probably find how that is done. I'm not going into detail here, but here you can see, yeah, we go to Key Vault, we get a service bus secret, and then we convert this into a Kubernetes secret, and we use the service bus key to do so. Let's just first apply this. So k apply, so alias to backfill, k apply -f, and we do kv secrets.yaml. That should actually create the secrets. So k get secret, there should be a secret called Dapr SB, yes. We want now to see Dapr SB, and we want to see the YAML here. There's the YAML. There we have the key called service bus, and let's take this here. This is the base64 encoded secret, and let's echo this out, but let's pipe it through base64 -d, and indeed that decodes the base64 encoded string, and this clearly looks indeed like a service bus endpoint to me. So we have this secret here. That means also we can create the component. So let's create the component. K apply -f PubSub component, and we do it like this. Component is now created. If you have the Dapr CLI installed, you can use Dapr components -k, and that will list out the components that Dapr knows about. In this case, Dapr on Kubernetes, not your local Dapr on your local machine, hence the -k that we are using there as a parameter. Great, we have the PubSub component there. Let's now deploy our subscriber. Yeah, the subscriber, as I told you earlier, it's just going to be a simple deployment, but we're going to have 2 replicas. So yes, 2 replicas will be deployed. And of course, just like in the other videos, we have to annotate this properly. So we say Dapr IO enabled true to get the sidecar, we give it a Dapr ID. And of course, in this case, we tell Dapr, hey, this one is listening on port 3000. So you can actually go there and try and find out what topics is this container interested in and how should you deliver these topics. Yeah. I already built the image. That one is this one, Dapr node sub. And of course, I tell him what container port to listen to. This should be enough for the subscriber to be up and running. And of course, the subscriber will use the PubSub system, which was defined through the PubSub component, to actually do the appropriate things. In our case, this means that at the service bus level, look at it here, there is no topic being defined. If we have expressed our interest in the topic called sample topic, and it's not there, Dapr will also create it for us, right? So if I create the subscriber with k apply -f sub.yaml. From the moment the subscriber is created, a lot of stuff is happening now. Dapr is doing that investigation to see are you interested in topics, and if so, what topics, and then if they're not there, let's create them. Let's just see what's going on, and if that is indeed the case, let's refresh. And indeed, suddenly we see the sample topic appearing here. The sample topic will also have a subscription created already by the Dapr component. Subscription is called NodeSub. And if messages are appearing and they're not being processed and so on, I could of course use Service Explorer or Service Bus Explorer here to do a peek at this level and check if there are any messages in this topic, which of course at this point in time, there are none. So that's our subscriber. At the Kubernetes level, we will have these 2 subscribers running. So we have a NodeSub deployment. The NodeSub deployment has 2 instances of our code, but of course, each container that we have also has a sidecar container. So we have 2 containers running in each NodeSub pub that is listed here. Now, without any messages appearing on the topic, that's not really very interesting. So let's also deploy the publisher. The publisher is just as simple, but because the publisher does not need to expose a port, we don't have to tell Dapr to go there. Actually, we shouldn't tell Dapr to go there because there is nothing there. We just deploy this publisher component. So k apply -f pub.yaml. This is the publisher. Let's check out the publisher as well. So let's refresh our deployments. Suddenly we see a node pub over here. That's the publisher, only one instance, but of course also with a Dapr sidecar. If we get the logs, follow the logs of our node application, not the sidecar, but the node application, we can see indeed that the publisher is busy posting messages at this point in time. And of course, we do hope that one of our subscribers are both. I can't really predict if they're both are going to be getting this. Sometimes I see them both doing it, sometimes not instantly. If I follow the logs of the subscriber, I see indeed this one, well, it's not doing that much. This one here, if I follow the logs of this one is doing all the work at this point in time. So sometimes you see some balancing, sometimes you don't really see it. It can depend on the timing as well. That's not too important. What you should know in this case is that Dapr is doing the correct thing to make sure that your application, the subscriber in this case, which is 2 instances, could be more instances, is getting just the data that it needs to have. So it doesn't, for example, send duplicate messages all the time, things like that. That's not something which is happening here. So that's fine. This is being processed. Of course, yeah. What happens when these subscribers are not there? Well, yeah, we can just simulate this by deleting the subscribers. Let's just do that just for fun. We delete our subscribers, which means that suddenly the subscribers are gone. The logs will of course stop working, but our publisher is of course sending messages still. If we go to our sample topic now and we peek into the topic, we should see that of course these messages are now piling up because there are no subscribers that can take them off the topic and process them. So this keeps on going and going and going until my subscribers start working again. Yeah, let's just do that. Let's just start the subscribers again. So let's do a k apply minus f again. That's it. And we have our subscribers will start running again. They should, when they start up, they should see, of course, all the messages within in our topic. And yeah, when we peak, they should be removed from the list, of course, because they're successfully processed by my subscribers, right? So that's clearly how that works. But basically, that's what PubSub is also all about. Now let's clear this out here for a moment, and let's just show a couple of things maybe still. First of all, it's maybe interesting to know that you can use Dapr to have a list of the Dapr applications running on your cluster. So in this case, we have node pub and node sub here. Just refresh this for a moment. Yeah, that is it. So we see these applications here. What we also can do is, for example, we can do Dapr logs and then do minus k minus a and then maybe node pub, and this will retrieve the Dapr sidecar logs of the node pub application. For example, what you can see here is that it saw something like our service bus here, found component PubSub service bus. What you can see here is clearly shown in the Dapr sidecar. Now, of course, you don't have to use this command. If you just go to your node pub and you do right click here, you do follow logs, and you select the Dapr logs, and you get, of course, the same logs being shown there, and it's maybe a little bit easier to follow along because you're doing a follow here of the logs, right? So that's basically it. I hope you have understood how PubSub works with Dapr. The key thing here is that my code is not really interested in the underlying PubSub system. It doesn't need to know about it. It contains, or it talks to Dapr sidecar containers. And depending on the underlying PubSub system, Dapr does the appropriate thing. It also does the appropriate thing when you have multiple subscribers, things like that. Of course, Dapr will try to do at least once delivery. So take that into account. If you need other kinds of things, you might do some things differently. But in this case, it will take care of everything to make sure you have this at least once delivery being taken care of, right? So that's it. Maybe in some other videos, or probably in some other videos, we'll look at some other components of that, or maybe the secret stores in a bit more detail. But that's it for now. Hope you enjoyed it. See you next time. Bye bye.